Okay, so we're going to start probability today, and we're going to talk about, it's really three things, but they're all connected. So we're going to talk about fundamental counting principle. I promise this is, it's pretty fast. And then we're going to talk about what we call permutations and combinations. And also we're going to mention some factorials today, but a lot of this is going to be stuff you can do on your calculator. Graphing or scientific, if you have scientific, I'm going to have to come look at it to find where the button is, but for sure if you've got a graphing calculator, you're going to want to use that today. Okay, so first things first, fundamental counting principle, also sometimes called the multiplication counting principle, because you're going to multiply. It says if you have an event M, so something is going to happen, and there's M different things that could happen in that event. So, I don't know, like, just if I want to pick out of 5 colors or something like that, there would be 5 ways I could do that. And followed by a second event, let's say I wanted to pick, I don't know, 5 different plants, like 5 different flowers. Then I would have 5 choices for that. If these 2 events follow each other, the number of ways you could put them together would be to multiply the 2 numbers together. So I would have M times N. I just explained that horribly, but we're going to do an example that hopefully will make it make sense. So I'm going to have us write these actually out. So this says in example 1, okay? I have salad, I'm going to order from a restaurant, and the salad is going to come with the choice of bread. So your salad, your choice here, this would be like event M, and this would be like event N, right? Okay, so for the salad, you have 4 choices. And for the type of bread you have 3 choices. So by this fundamental counting principle, my answer should just be to take the number of choices I have for the first times the number of choices I have for the second, multiply those together. There should be 12 choices. But what I'm going to actually have us do here is just write these out to show this to you real quick. Okay, so for the salads, you got Greek salad, pasta salad, house salad, fruit salad, and then you can pick to have toast, you can have a breadstick, or you can have a muffin with that. So I'm just going to write these out. So like, let's say I pick the Greek salad, then I have 3 choices. I could get the Greek salad with toast, I could do the Greek salad with a breadstick, or I could do the Greek salad with a muffin. So there'd be 3 options just right there. If I pick the pasta salad, again, I have the 3 choices of bread. So I could do pasta salad with toast, pasta salad with a breadstick, or pasta salad with a muffin. So there's 3 more. If I pick the house salad, same thing. I can do the toast, the breadstick, or the muffin. And then I've got the fruit salad. So same thing again. Fruit salad, we could get the toast, we could get the breadstick, or we could get the muffin. So these are all different ways that I could pick how I want the salad and the bread that comes with it. And you guys can see, if you count these out, right, I've got 4 different choices: the Greek salad, the pasta salad, the house salad, and the fruit salad. And then I have the 3 choices. So there we wrote down, there's 12 different options there. And it was just 4 times 3. So that's the multiplication counting principle. You don't have to write all of those out. If you have the choices, you can just multiply them together. Okay, and then to the side here, this just says, how many more choices would you have if you could also pick to put on your salad chicken or steak? So if I'm adding that into the mix, then with my salad, just as an example, like I could get, let's say I got the Greek salad with toast, and then I could get chicken with that, or I could do Greek salad with toast, or I could do steak with that. So for each one of these that we already wrote down, that would add in 2 choices for each one, which would be the same as just multiplying by 2. So basically this third category here, chicken or steak, that's 2 more options that I'm adding into that. So it would just be 4 times 3 times 2, which is just going to be then 24 options. So you can, the fundamental counting principle doesn't have to just be 2 events. It could be 3 events, 4 events, 5 events, 6 different things. You're just going to take the number of options you have in each category and multiply them together. That would give you the total number of different possibilities you have without writing them all out. Is anybody having a question? Okay, now this question is also fundamental counting principle, but it's a little bit different the way I want to draw this. So I have two license plates here, just little examples. The one on the left side is from 2004, and this one is really old. This one is from 1912, both of these from the state of Maryland. And it says, how many more of the 2004 style choices do we have than the 1912, just to compare these. So this is a little weird. All right, and it does say, this is important because we're going to do a different question underneath this. The letters and the digits, they could be repeated. So like this could say, you know, ABA or whatever. I can repeat stuff. So I'm just going to write this out. I have 3 letters in this license plate, and then I have 3 numbers. Okay, so my first event here would literally just be like the first slot in the license plate. So if I'm just going to pick a letter at random, how many choices would I have to pick any letter? Do you know how many letters are in the alphabet? Okay, just checking. Okay, so I would literally have 26 choices. Okay, my second event would just be to pick another letter, and it's okay to repeat. So I would have 26 choices again, right? And then the third event would be a third letter, so I'm 26 again. We're just going to multiply these guys together. Okay, now this is a little weird for people to think about. So I'm going to pick a digit. So that could be any digit 0 through 9. If I pick a digit at random, 0 through 9, how many choices do I have? 10. Okay, so some people think about it. So you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's actually 10 different choices. And if I can repeat it, for that second number slot there in the license plate, I'd have another 10. And for that third, I would have another 10. So to get the total number, and this is going to be a huge number, total different number of license plates we could make, we're just going to multiply these guys. So 26, 26, 26, 10, 10, 10. And then it's a huge number. It's 17,576,000 different license plates that we could make. Okay. Now, the 1912 one, obviously not as many people have cars then, so they just had 4 digits. So if they can be repeated, I'm just going to make this little bitty license plate, it's just going to be 4 digits. So it would just be, if we can repeat the numbers, you'd have 10 choices for each number slot. So we could just do 10 times 10 times 10, or we could just do 10 to the 4th. So this is a very small number compared to that, so that would only be 10,000 choices. Now, the actual question just says, how many more license plates will we have? So what I would actually do to answer the question here is I'm just going to subtract these two numbers. So that would just subtract 10,000 off of what we have. So the answer to the question would be 17,566,000 more options when we add those letters in to the mix with our license plate. And obviously they can make license plates more complicated so they can create more options there. Now, this one's a little bit weird, but it's related. So it says, how many of each type of license plate if I can't repeat the letters and numbers? Okay, so I'm going to do the same thing, but I can't repeat the letters and numbers. So I'm still going to have 3 letters followed by 3 numbers for that 2004 license plate. And if I can't repeat letters, I can't repeat numbers. Just think about this for a second. So for my first slot, I would still have 26 letters to pick from, right? If I can't repeat the letter, then I can't use what I just used. So how many choices would I have for the second letter? 25, all right? And then if you've used 2 of them for the third slot, how many would I have? 24. Okay, so you're just taking one away each time. Now, for the numbers, kind of the same thing. You'd have all 10 digits to choose from for the first slot, but if I can't repeat, I've used one of those, so then I would only have 9 options for the second, and then if I've used 2 of them, I'd only have 8 options for the third slot. So this is going to be fewer. It's still going to be a bunch, but this way I'm not repeating any letters or numbers. So I'm going to do 26, 25, just multiplying these guys together. And it's still a huge number. I've got 11,232,000 5,000 different license plates there. Now, with the 1912 one, if I can't repeat any digits, this is going to be far fewer. So I only have 10 options for the first slot, then I've used a digit. So then I would only have 9 options for the second, 8 for the third, and 7 for the fourth. So if I multiply that, this one's going to give me only 5,040 license plates that I could make. Is anybody having a question? Okay, now, for what we call a factorial is like a special case of the fundamental counting principle, where basically I'm going to use all the letters or all the number, like I would use all the letters in the alphabet, or I would use all 10 digits or something like that as an example. And it looks like this, n factorial, it looks like a little exclamation point. It is a little exclamation point. So it says for any positive integer n, so a positive number, nice number, not like a decimal, n factorial. I'll give you the technical definition, and then I'll kind of do it with a number to hopefully make it make more sense. But you would take the number, so n, times the number before it. So I would represent that with n minus 1. And then times the number before that, we would represent with n minus 2. And then you would keep that pattern going. I'm going to put a dot, dot, dot. And it would end with multiplied by 3, multiplied by 2, multiplied by 1. It depends on how big the number is. So I just put a number underneath here to kind of explain this. So I did 5 factorial, right? So what this means, 5 factorial, you would take 5 times 4 times 3 times 2 times 1. That would be how you would calculate 5 factorial. Okay, now, if it's a small number like that, that's probably no big deal to just type into your calculator. So we could do that, and I could just do 5 times 4 times 3 times 2 times, I really don't need the times 1 because that's not going to affect it, but this would be 120. Now, if you have a graphing calculator or a scientific, I'm going to have to look at your scientific if that's what you want to use, but there is a factorial button under a menu. So what you would do on your calculator, you would type whatever you were going to do. We're going to do, I'll do 5 factorial, or if you want to look down to the bottom, we're going to do 8 and 12. So if you want to do one of those. So you would literally type the number, and then to get to the factorial, you're going to hit the math button, which is the 4th button down on the left side here. So I'm going to type, I'll type 5, hit math, and then on that screen, you got to arrow over to the menu. It says PROB, that stands for probability. And then you guys will hopefully see the little exclamation point. It's number 4 on that screen there. And if you hit enter, it should take you back to the main screen and then show you 5 factorial. And then you can see that's exactly the same as what I just got, which was 120. So you got to type the number first, and then hit math, get that probability menu. And then I think it's number 4. It might be different depending on which calculator you have, but I'm pretty sure it's the 4th option down, or it should at least be in that probability menu. So see if you guys can try the 8 factorial or the 12 factorial there on those next examples. And if anybody's having trouble finding it, I'm looking at it for you. Anybody having trouble finding those in the calculator at all? All right. Here, I'm going to write these out. Hopefully you guys got these. This one should be 40,320, and this guy should be, oh, this is a huge one. I got 479,001,600. Oh, I don't know why. I just can't write a number apparently. Sorry. 479,001,600. Anybody not getting those? Okay. Now, The factorial, like I was saying to you, it's a special case of that fundamental counting principle where we're going to organize everything in a group. So, little example here. It just says, in how many different ways can you arrange 6 trophies on a shelf? So, if I have 6 trophies and I'm going to line them up in a particular order, and you don't have to write this, but you could do it kind of like how we did the license plates. You got 6 things, right? So I'd have 6, 5, 4, 3, 2, 1. Just multiply those all out, because I'd have 6 slots for the first trophy, then I've used one of them. Then I'd have 5 for the next, then I've used 2 of them, and then on down. Or you can just do the 6 factorial, whatever is faster for you, but both of those would work in that situation. So 6 factorial should end up being, I think it's 720. Yeah. So there would be 720 different ways that I could take 6 trophies and line all 6 of them up on the shelf. So factorial is a special case of your fundamental counting principle, where you're going to organize everything. So this one says, how many different ways could I put 10 file folders in my desk? Well, I could write that out, do like 10, 9, 8, 7, 6, or I could just do 10 factorial on my calculator, answer that question real quick, and that should be a lot larger than what we just did. This should be, I got 3, 6, 2, 8, 8, 0, 0, so I've got 3,628,800 options for that, to put 10 file folders in a certain order in my desk. Is anybody having a question? Okay, now what we're going to talk about back permutations and combinations, and I just have a lovely little graphic at the top to kind of illustrate the difference between the two. So this just says, in how many ways can you organize the numbers 1, 2, and 3? And then to the side, I just have this little tiny chart. Okay, I didn't mean to draw that line that big. So if the order matters, then I would have all these different ways. There'd be 6 different ways that I could organize 3 numbers if the order mattered. Okay? And if the order matters, I'm just going to put a P here. If the order matters, that is what we call a permutation. And if you want to, right underneath here, a permutation, an arrangement of items in a particular order where the order does matter. Okay, so in that situation, I would have 6 different ways I could do that. The other one we're going to talk about here in a second is a combination. In a combination, the order doesn't matter. So in a combination, you could see for a permutation, I have 6 options. For the combination, that same thing would just be 1 option. So there's fewer combinations than permutations of the same number. And then permutation, it's pretty similar to the fundamental counting principle. But if the order does matter, how many options do you have? And this is the formula for it, which you guys don't have to memorize this or anything. We're going to do this on the calculator. So number of permutations, n. N has to be the total that you're picking from. So that has to be the bigger number. And then this is, the R is how many you pick. So that should be the smaller number when you do this. So the total you're going to go out of and how many you're going to pick. The formula for it you can see right below, and then I've got a little example that's got numbers for you guys to see from the side there. But there is an actual button that will do this for you on the calculator. So the permutation, the order matters. This one right here, just to show you where the button is at, it's 25, and out of the 25, we're going to organize 7. I know 25 what? I don't know. Maybe it could be 25 students. We're going to line people up in a certain order, and I'm going to pick 7 people as an example. This is going to be that same menu, but the difference here, if you have an 83, if you have an 84, don't worry about it. If you have an 83, TI 83, you have to type the 25 and then do what I'm going to do if you have an 83. If you have an 84, all we're going to do is we're going to hit that math, arrow over to that probability menu, and I think, let's see, it is NPR for permutation. It's the second one down. So for the permutation, just go ahead and click on that. Now, here, if you have an 84, you can just go ahead and type the 25 and the 7 right in. The bigger number has to go first or it won't do it. So out of 25, I'm going to pick 7. Once you type that in, just hit equals, and it's going to tell you this is going to be a huge number of different things that you could do. If you have an 83, you just have to type the 25, the first number, before you actually put that into the calculator. Or if you want to use the formula, it's right there. You can plug it into the formula as well. But this is a huge number of different options. And we're going to do this with a combination in a second. But I'm at 2,422,728,000 different ways if I had 25 items and I wanted to organize 7 of them. But you got to read through the question to see if the order matters. So here's just a couple examples. So this says if a teacher has 9 math books, but only room for 7 on the shelf, how many possible arrangements of books are there? Yeah. Okay, so the only thing that would be different, like I would just type the number 25, and then do that math probability number 2, and then you would type the 7 after it, and it should give you that same thing. Yeah, that's the only difference. If you have an 84, it'll just automatically pull that up for you. Really good. Is anybody else having trouble with their calculator? I'll come look at it in 1 second. See if you guys can try this one. Okay, so teacher has 9 math books. I'm going to arrange them on a shelf. Now, the order does matter here because it would be different if I put the algebra book and then the geometry book. It would be different if I put the geometry book and then the algebra book. So that would be a different order. So this, I have 9 books to take and pick from, and I got to organize 6 of them. So see if you guys could try that on your calculator. That'll tell you how many different ways you could do. You guys are welcome to borrow them. Okay, so 9 math books. Out of that, I'm going to pick 6 of them. So hopefully you guys are getting, I got 60,480. Is anybody not getting that? Okay, let me finish this up real quick. 8 people run a race, first, second, and third. So the order would matter. If you finish first, that's different if you finish second or third, right? If you get gold, silver, and bronze, something like that. So if you have 8 people running the race, out of them, you're going to pick 3. The order does matter there because your placement would give you a different level, right? So I'm just going to do exactly the same thing. Just hit that. If you got an 83, just type the 8 first, but if you got an 84, just go ahead and hit your probability menu, NPR. You got to start with the bigger number, which is 8 people total. Out of that, we're going to organize 3 of them. So there would be 336 different ways that those people could finish first, second, and third that would all be different. Now, the other one that we talked about at the top of the page there real quick, this is far fewer options. A combination, the order does not matter. All right, and it's going to be in that same menu on your calculator. And I'll show you, this is the same exact numbers we used at the top. 25 in combination, I want 7. So the combination should be a much smaller number than your permutation because it's going to weed out any of the repeats. So like if you look at this thing at the top, 1, 2, 3, 1, 3, 2, 2, all these would just be this one option in a combination if the order doesn't matter. So there will be fewer combinations than there are permutations. So to get to this, it's that same menu. You're just going to hit math and then the probability menu. And then this one will be number 3. And it will be NCR on there. The N is the total number. The C just stands for combination. And then the R stands for how many out of that you want to pick. So for our little example here, I'm going to do 25 and I'm going to do 7 that I'm going to choose out of that 25. So it should be a smaller number. It's still pretty big, but it's smaller than the number of permutations. So I got 480,700 for that one. Okay, so the order doesn't matter for a combination. So does the order matter? Does the order not matter? That's what you want to ask yourself. So for these two little examples at the bottom, these are both combinations. It says chemistry teacher divides the class into 9 groups. So I have 9 groups of people. Each group submits a drawing of molecular structure of water, if I can talk, and the teacher's going to just display 4 of the group's work. So it doesn't matter the order. It doesn't say anything about, like, I'm going to hang this one up first and this one up second. So I'm just going to hang up 4 drawings. Everybody's going to look at all of them. Doesn't matter the order. So this would be 9 groups, and out of that, the teacher is going to choose 4 of them. So if it's a combination, I'm just going to display these 4 groups. It doesn't matter the order. We're just going to go ahead and hit that lovely math menu. And so I've got 9, and out of that 9, we're going to have 4 groups works displayed. So there would be 126 different ways the teacher could pick that out to display 4 groups. Same thing below. The order doesn't matter here. It says how many different teams of 11 players can be chosen from a soccer team of 16. So bigger number has to go first. I got 16 people. It doesn't say anything about this person's going to play this position or anything like that. It just says how many different 11 player teams can we form. So 16, and we're just going to pick out of that group 11 people. So doesn't matter the position. That's how it's going to tell me that the order doesn't matter. The bigger number always has to come first when you type these in, or it won't do it. It's the total number you have, and then how many out of that group you want to pick for the combination or the permutation. Is anybody having a question?